Alright, so today we'll be talking about first derivative tests. And first derivative tests can be used to find relative maximums and minimums. Okay? A relative maximum is going to be a point at which the function f switches from increasing to decreasing. Right? If we have a function that is increasing and it switches to decreasing, that is going to cause a maximum point. It might be the absolute maximum, but it is at least a relative maximum point, right? There. So, if our function switches from increasing to decreasing, the derivative is going to switch from what to what? If our function is increasing, derivative would be positive. And if our function is decreasing, the derivative would be negative. Okay? Whenever you justify a relative maximum or minimum, and there will be several where you have to do this, you must talk about the derivative, because this is just the general definition for a relative maximum. So if you say that there's a relative maximum because f switches from increasing to decreasing, you're just telling me the definition of a maximum. So it doesn't really show me you know anything about why it has to be that. It's just telling me you know the definition of a relative maximum. So you have to show that the derivative switches from positive to negative. So to justify, to prove that there has to be a maximum there, you have to talk about the derivative. If you just answer it talking about f, then it won't be correct. Relative minimum is similar. It's where we switch from decreasing to increasing. That's going to cause a relative minimum point. Could be an absolute, but it's definitely at least a relative. Therefore, if our function switches from decreasing to increasing, then the derivative is going to switch from, if we have a function that's decreasing, our derivative would be negative. And then if our function is increasing, our derivative would be positive. A quick word of warning. I think that on the AP exam, if you just put a plus sign and a negative sign, they're probably going to take it. Probably. However, I would write the words out, because it is really easy for your plus sign or your minus sign to get lost or not interpreted correctly, particularly if your writing is a little bit messy, if you're rushing through. So I would write the word out. You're taking a risk anytime you shorten that up there, so I would write it out. Okay, so for this equation, we are supposed to find all relative extrema of this function, and we must justify our answers. So if we're looking for relative extrema using the first derivative test, we are going to take our derivative, and then we need to see where that derivative is positive or negative, because that'll tell us where our function is increasing or decreasing. And from there, we can decide where we have relative maximum and minimum. So this is going to be a lot like you were doing on your homework over the weekend. You're just looking for something different. So you're going to take first derivative here. Wesley, what's our first derivative going to be? Good. Once we take our derivative, we're looking for critical points. We're going to set this equal to 0. I would go ahead and divide off a 6. Since 6 goes into all of these evenly, it's going to make it easier to factor. So x squared minus 5x plus 6 equals 0. That is going to be x minus 2 and x minus 3. And you factor it, and that'll be x equals 2 and x equals 3. So these are our critical points, or critical numbers. Now, it is important when you plug back into the derivative, you want to make sure you're plugging into the original derivative. I would do this. That 6 that we divided off, maybe I really shouldn't have divided it off. Maybe I should have left it kind of like out here, like that. As far as solving goes, it's fine to divide it off. But when it comes to plugging back into the derivative, you need the 6 there. It's not going to make a difference in this case because it is positive, but if it is negative, it makes a difference in your answer. So you don't want to just throw away those coefficients that you factor out. So if I'm plugging into my derivative, on my number line, I'm going to put 2 and 3. And then the parts of my derivative, I've got 6, I've got x minus 2, and I've got x minus 3, which will give me f prime of x. So I can make my chart. And then when I fill it in, 6 is always positive. You can get away with leaving it off since it's always positive. If it were a negative number, you cannot get away with leaving that off. It would change your answers. X minus 2, if I plug in something like 0, I'll get a negative, but then anything bigger than 2 is going to give me a positive. For x minus 3, if I plug in something like 0, I would get a negative. I'll also get a negative here, but then anything bigger than 3 will give me a positive. Okay, questions so far? Yes?
You just never factor out a negative number, just always factor out a positive.
You could, yeah. It just, if you still have a negative right here when you're factoring, if your x squared is negative, it just makes it a little difficult to factor. So, and you also, like, you don't have to do the chart. You could just pick numbers like plug 0 back into 6x squared minus 3x plus 36. So, if you don't like making the chart, you can just plug back into the derivative. So, if I've got 2 negatives in this column, that'll give me a positive. I've only got 1 here, so that'll give me a negative, and then a positive here. All right, so if my derivative is positive, that means my function is increasing. And then here I go to negative, which means my function is decreasing. So what do I have right here at 2? Relative maximum. And at 3, what am I going to have? Relative minimum. Now, it's very likely that you're going to have to find these relative maximum and minimum values. So, the actual maximum point or maximum value would be the y-coordinate. The x-coordinate is where that occurs. The way they have asked us here, it just says find all relative extrema. So I would use both coordinates here. So for the sake of time, let's just use the calculator real quick for this. This would be calculator inactive, but just to speed it up just a little bit. If I plug in 2 times 3, times 2 to the third minus 15 times 2 to the second plus 36 times 2 plus 10. Oh wait, I didn't close this parentheses right here. Alright, that gives me 38. So here I've got the point 2, 38. And then if I plug in 3, 2 times 3 to the second minus 15 times 3. Oh wait, that should be to the third. 3 to the second plus 36 times 3 plus 10. 37. So I've got 337. All right, so you would justify this by saying f of x has a relative maximum at 238 because f prime of x switches from positive to negative at x equals 2. Now, it's okay to say which means that f switches from increasing to decreasing, but you don't have to say that. You just have to talk about the derivative. It is not okay to say f has a relative maximum at 238 because f switches from increasing to decreasing, because that's just definition of relative maximum. It doesn't show us that you proved anything from your derivative there. And then you would also have to say f of x has a relative minimum at 337 because f prime of x switches from negative to positive at, I should say at, x equals 3. Just labeling these without explaining it with a sentence is not going to get you full credit on a free response. So you have to write that out. Okay, questions? All right, all relative maximum and minimum points for f of x equals sine x plus cosine x on the interval from 0 to 2 pi. So for this one, same thing as the last one, we need to take a derivative. So derivative of sine is cosine. Derivative of cosine is negative sine. Once we have a derivative, what do we do with it? Set it equal to 0. Now, this one's basically, if we move that sine over, it's just where cosine x equals sine x. So if we think about the unit circle, where does that happen? Where do we have the same values for cosine and sine? Right here at 45 degrees, which would be pi over 4, we would have root 2 over 2 and root 2 over 2. So x equals pi over 4. Where else? 5 pi over 4. Because over here at 5 pi over 4, we would have negative root 2 over 2 and negative root 2 over 2. So we're going to put those values on our number line, and they gave us an interval to look at here, so from 0 to, we got pi over 4, and we got 5 pi over 4 and 2 pi. This one is asking for relative maximum minimum points. If it were asking us for absolute, we could just plug all of these numbers into the original function. We could do 0, pi over 4, 5 pi over 4, and 2 pi. And that would help us find the highest value would be absolute maximum, lowest value would be absolute minimum. When we're looking for relative maximum or minimums, we might have a relative maximum or minimum that is not the highest or lowest point. So we've got to check increasing, decreasing here. So f prime of x, I'm going to label here. All right, so if I plug in a number between 0 right here and pi over 4, so if I highlight this right here, I'm looking at this section of the unit circle is corresponding to right here. All right, so Connor's telling me positive. Why? Okay, cosine is bigger than sine on this section. Cosine is your x coordinate, and sine is your y coordinates, right? And if you need a point to check, pi over 6 is the only one on the unit circle that we know. And at pi over 6, right here, pi over 6, we would have root 3 over 2 and 1/2. So we would end up with root 3 over 2 minus 1/2. That would be positive, right? So we're going to get a positive there. So if we think about what's going to happen on the next section, so pi over 4 to 5 pi over 4, we're looking at this part of the unit circle, right? I could pick lots of different points to plug in. I could just sort of reason through it. Something like pi over 2 would be good. I have 0, 1 at that point. So if I do cosine minus sine, 0 minus 1 at pi over 2, that would give me a negative number. So I'm going to be negative right there. And more than likely, we're probably going to be positive on this next section. But this section here corresponds with this part of the unit circle. You can pick anything in that section. Probably one of the easiest ones is 0, negative 1. And if I do cosine of 3 pi over 2 minus sine of 3 pi over 2, that is 0 minus negative 1. That double negative is going to give you a positive 1 there. So you get a positive here. And I'm going to change the question here just a little bit to say this a little, well, that's not too bad. Okay, so relative maximum and minimum points. We are going to have right here, we go from positive to negative, so that's a relative maximum. And then from here, we go from negative to positive, that is a relative minimum. So, if I do f of pi over 4, that is going to be, we're plugging into the original there, so it's going to be sine of pi over 4 minus cosine of pi over 4, right? Plus, which is going to give us root 2 over 2 plus root 2 over 2. That gives us 2 root 2 over 2. 2's will cancel, so you just get square root of 2. So we got the point pi over 4, square root of 2. And we would say f has a relative maximum at pi over 4 root 2 because f prime of x switches from positive to negative. And we need to do the same thing for 5 pi over 4. So 5 pi over 4 going to be sine of 5 pi over 4 plus cosine of 5 pi over 4. So that is going to be negative root 2 over 2 plus negative root 2 over 2, which will give us negative 2 root 2 over 2, which is negative root 2. So we've got the point 5 pi over 4 negative root 2. And we would say f has a relative minimum at 5 pi over 4 negative root 2 because f prime of x switches from negative to positive. So anytime it asks you about relative maximum, relative minimum, you should be talking about how the derivative switches from positive to negative or negative to positive. If it's asking you about increasing or decreasing, like the first ones we were doing today, it is going to be because your derivative is positive or your derivative is negative. But if it's asking for the relative maximum or minimum, you got to talk about the switch. Questions there? All right. Let's see. Let me see what we got. Let's we need to do this one. All right, whenever I've got f of x equals cosine squared of 2x, what rule am I going to have to use to take this derivative chain? Okay, it may help you to think of this. You got f of x equals, this is like cosine of 2x squared. So not only is it a chain rule, it's really like a triple chain, right? Because your outside is that stuff being squared. Then on the inside, you've got the cosine, and on the inside of that, you've got the 2x. So to take this derivative, we're dealing with the 2 first, right? So it's going to be 2. We're going to leave this stuff alone, cosine of 2x, that doesn't change, to the first power. Then we have to take the derivative of the green box. What's that going to be? Derivative of cosine is negative sine. Make sure you put a multiplication here so it doesn't look like you're subtracting sine. So times sine of 2x. And then finally the derivative of the inside, that 2x, which would be 2. So you've got a 2, a negative, and a 2 here, so that's going to be negative 4. And then you got cosine of 2x sine of 2x. This is our f prime of x. Questions so far? What do we need to do now? Derivative equal to 0. So you would have negative 4 equals 0, but that does not give you anything. You'll have cosine of 2x equals 0, and you will have sine of 2x equals 0. So let's look at think about our unit circle. All right. They only asked us to look from 0 to 2 pi, or to pi. So 0 is here, pi is here, but we're actually going to have to look a little further. We'll see. We got pi over 2 and 3 pi over 2. And our coordinates are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So, ignore the 2x for right now. Where does cosine equal 0? At pi over 2 and 3 pi over 2, right? But we've got a 2x here. So it's not going to be x equals pi over 2 and 3 pi over 2. We're going to get 2x equals pi over 2. So to solve that for x, I need to divide by 2, or it's going to be a little easier to think of by multiplying by 1/2 here. So x would equal pi over 4. Now, 3 pi over 2 is not between 0 and pi, but look what happens when you do this. 3 pi over 2 is not in the interval that we're supposed to be looking at. But I've got 2x equals 3 pi over 2. So if I multiply both sides by 1/2, I get x equals 3 pi over 4. Does that fall between 0 and pi? It does. So we need to look at really twice the interval that they're telling us to look at, because we're going to end up having to divide it by 2. So rather than just look from 0 to pi, we're going to look at the whole unit circle here. All right, so that takes care of our cosine. We got 2 values here. For our sine, sine is going to equal 0 at 0. So that's just going to give you x equals 0. It is going to equal 0 at pi. So 2x will equal pi. If we divide by 2 there, we get x equals pi over 2. And it also equals 0 at 2 pi, which is not in the interval we're looking at, but when we divide it by 2, we get x equals pi, and that is on the interval that we're looking at. All right, are we okay here? So, critical points, we are going to have 0, pi over 4, pi over 2, 3 pi over 4, and pi. And I'm going to make a chart for this one. This is where it's important here that you've got that negative 4 right there. That's going to matter because it's negative and it's going to change your answers if you leave it off. And then we also have cosine of 2x, and we have sine of 2x, and then we would have the derivative itself in our table. All right, so negative 4 is always negative, so we want to include that there. We don't have to look past pi because they only told us to go from 0 to pi. All right, so plugging into these can be a little bit trickier. For example, between 0 and pi over 4, the only unit circle value we know is pi over 6. So you can plug this in, like this pi over 6 would be here. So if I do cosine of 2 times pi over 6, that would be cosine of pi over 3. Is cosine of pi over 3 positive or negative? It's going to be right here. And in this quadrant, we know we're positive, so we get a positive right here. Between pi over 4 and pi over 2, the only one we know there is pi over 3. But whenever we plug that in, cosine of 2 times pi over 3 is going to be, cosine of 2 pi over 3. On our unit circle, 2 pi over 3 falls right here. And we got negative positive in that quadrant. Cosine would be negative there. Pi over 2 and 3 pi over 4, you could use something like, what do we have there? We've got 2 pi over 3. But whenever we plug it in, we're going to have cosine of 2 times 2 pi over 3, which is cosine of 4 pi over 3. So 4 pi over 3 falls right here in this quadrant. Cosine and sine both are negative there. And then for the last one, between 3 pi over 4 and pi over 4, you could use 5 pi over 6. And cosine of 2 times 5 pi over 6 is going to give you cosine of 10 pi over 6, which reduces to 5 pi over 3. 5 pi over 3 falls over here. In that quadrant, cosine is positive, so you would have positive there. Now, I marked these on the unit circle here. Something similar is going to happen with all of these. So I'm going to write all of these down. When I do this line for sine, the same thing's going to happen, right? We got 2 times pi over 6, which is pi over 3, right? What is sine of pi over 3, positive or negative? It is positive, so we get a positive here. Then we would have, when we plug in pi over 3, we would get sine of 2 pi over 3. What is sine of 2 pi over 3, positive or negative? It's still positive because it's our y-coordinate there. The next one, 2 times 2 pi over 3 is going to give you 4 pi over 3. That's was cosine, but now we're looking at sine. We're going to get a negative there. Both are negative there. And then this last one, we're going to be over here, which is going to be negative for sine. Okay. So odd number is going to give you a negative. Even number gives you a positive. So we end up with negative, positive, negative, positive. And for the sake of time, I'm cheating on this one because there's a lot to write out here. We're just going to label them and move on because I want us to get to a couple other questions. So this pi over 4, what would I have there? Relative minimum, because I'm going from negative to positive on my derivative, which means my function goes from decreasing to increasing. At pi over 2, I would have a relative maximum. And at 3 pi over 4, I'd have another relative minimum. And if this were for a response question, you would need to write all that out, find your y-coordinates, do all of those things. But for the sake of time, we are not going to do that right now. Okay? All right. 4 looks worse, but it's actually not, because what have they given us for 4? They gave us the derivative. You don't have to find the derivative. So if this is the derivative, you could go straight to making your chart. So if we set this numerator equal to 0, we'll get x equals -4 and x equals 3. If we set the denominator equal to 0, we'll get x equals 0 and x equals 1. So on our table, we would have -4, 0, 1, 3. And then I'm just going to list all of the pieces. So I've got x plus 4, x minus 3, I've got an x, And I've got x minus 1, but that x minus 1 is squared. And so that's f prime of x will be last there. So I'll make myself a chart here. And so what you'll find when you're filling these out is that you're going to switch from negative to positive or positive to negative at the point where you have that 0. So anything below -4 is going to give you a negative, but then anything bigger than -4, so like -3, you're going to get positive, and it's going to stay positive for the rest of the time. So for this next row, you would get negative, 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 positive. Okay, all these numbers below 3, if you plug in something less than 3, like 0, you're going to get a negative, but anything above 3 is going to give you a positive. For the x, if you plug in a negative number, you get a negative number. If you plug in a positive, you get a positive. What about the line for x minus 1 squared? Always positive because of the square there. So your answer here, you would have a negative, a positive, a negative, another negative, and a positive. They usually switch back and forth, negative, positive, negative, positive, negative, positive, but you can see in this case it does not. And we would explain this, but for sake of time, we have a relative minimum here. We would have a relative maximum here. We would not have anything at 1. We have neither a maximum nor a minimum. It's still a critical number, but it does not give us a maximum or minimum point. And then right here, we'd have a relative minimum again. Okay, questions? All right, we do not really have time to do these last couple. We may try to do maybe like 4 as a warm-up tomorrow. So you guys have, let me look at this and see if there's anything that we did not get to here. 233. Oh, yes. If you guys will pass up your warm-ups, that would be lovely. I'm going to take out 41 and 45. We didn't do a piecewise, and we didn't do an E. 53. We did some trig. Okay, I'm taking out 4 of those. So 41, 45, 53, and 66. You do not have to do those.